Welcome learners to Form 3 Mathematics. Today I would like us to look at matrix method of solving simultaneous equations. Let us look at this question here that carries 10 marks. Here we go. Given the simultaneous equations 5x plus y is equals to 19, negative x plus 3y is equals to 9, write the equations in matrix form. Hence, solve the equations. So, we write these two equations in matrix form. So, what do? You first check on the letters, on the arrangement of letters, learners. You have x here, you have x down here. You have y, you have y. So, learners, you check on the arrangements and you make sure that x's are in the same column and y's also here, they are in the same position. So from there, you come and pick the coefficients of those terms. Pick the coefficients. What is the coefficient of x here? It is 5. What is the coefficient of y? It is 1. The number that multiplies y here is 1. Then you come to this other one. Coefficient of x here, learner, is negative 1. There is a 1 here. So negative 1. And the coefficient of y, learner, here is 3. The number that multiplies the letter. There we are. From there, you pick your x and y. You start with x and then you write y. Come and form a matrix here, x, y. Like that. The way they follow, one another. From there, you write equal to what? Put a matrix here which is 19, 9, 19, 9. And that is our matrix equation. You check on the letters, the arrangement of the letters. If they are okay, you move on and pick the coefficients of x and y, and then you put a smaller matrix xy and you equate it to this other left hand side where you have 19 and 9. From there, learner, we are meant to solve this simultaneous equation. So how do you solve this? The first thing is to find the inverse. Inverse, learner. Inverse of this 2 by 2 matrix. How do you find the inverse of a 2 by 2 matrix? You first find the determinant. Maybe I can write it in short like that. Determinant. What is the determinant of this 2 by 2 matrix, learner? You talk of multiply 5 by 3, the elements in the leading diagonal, then you subtract the product of the elements in the secondary diagonal. So 5 times 3, this is 15, minus negative 1 times 1 is negative 1. Look at that, learner. 15 minus negative 1. This gives us what? 16. Minus followed by minus is plus. So gives us 16. Therefore, learners, what is inverse? What is this inverse? The inverse will be 1 over 16. You introduce a new numerator 1 over the determinant. Then you put a matrix here. Which matrix? You go back to your original matrix, learner. You exchange the elements in the leading diagonal. So you talk of 3 comes there and 5 comes there. Okay? From there, you now negate the elements in the secondary diagonal. Negate them. So this will be negative 1. You write it there. Negative 1. And this will be negative 1, which will be 1. Negative 1, which will be 1. That is the inverse, learner. From there, you now, the second step is pre-multiply. Look at this, learner. Pre-multiply both the sides of the matrix equation with the inverse. Pre-multiply both sides of this matrix equation with the inverse. Pre means, as you multiply, you put this inverse before what is on the left hand side and what is on the left hand side. So you start with this here. So you put it here and also on this this other side, you put it in front of this matrix. You fix it here. So let us fix it. So you have 1 over 16, 3, 1, negative 1, 5. Multiply the left hand side of the matrix equation. 5, negative 1, 1, 3, xy. There we are. We have to put it before. Then on the other side, again, you do the same. 1 over 16, 3, 1, negative 1, 5, and then you write your 19 and 9. There we are. We now multiply the inverse and its matrix. If you have an inverse learner, aim with a negative there, negative 1. This refers to inverse of a matrix A. We said that in class when we are learning, we normally conclude that a matrix times its inverse normally gives us an identity matrix. I hope you can see that. A matrix times its inverse, they give us identity matrix. Identity matrix is 1, 0, 0, 1. That is the way we write in the identity matrix, remember? So you come here, you don't need to keep on multiplying these two, because you will finally get an identity matrix. There we are. So you multiply it with xy is equals to what? On this other side, do the multiplication. First, write the fraction outside there. Then you multiply these two matrices. Okay? So how do we go about this? Multiplication is row times column as you add. Remember? Row times column as you add. So we multiply 3 times 19 Lana. Maybe I can write here for the sake of understanding. 3 times 19 gives us 57. Plus what? Negative 1 times 9 gives us negative 9. Remember multiplication of matrices? So row times column as you add. This times this is 57. This times this is negative 9. Then you add. This will give you what? 57 minus 9, which is 48. Come and fix it here. We are done with the first row. We go to the second row. Lana. This times this as you add. This times this is 19. Check on that. 19 plus what, Lana? This times this is 45. Matrix multiplication. This times this. This times this is 19. This times this is 45. You add, you get 64. There we are. Come and fix it here, Lana. 64. From there, Lana, we move on. An identity matrix times a matrix. It does not change the matrix. The matrix remains the way it was. In other words, if you said row times column, Lana, you see this would be x plus 0 gives you x. We go to the second row. This times this. This times this is 0 plus y gives you y. So identity matrix times a matrix, Lana, you get the same matrix. So you then equate it to what, Lana? You multiply 1 over 16 with the elements inside here. 1 over 16 times 48, you get what? 3. 1 over 16 times 64, Lana, you'd get 4. There we are. And therefore, what is our x, Lana? Our x is 3, and our y is 4. Those are the values of x and y after solving your simultaneous equations. From there, Lana, we have a part 2. That was part 1. Maybe you can write it here. Look at this. You are told to find the distance of the point of intersection of lines 5x plus y is equals to 19 and negative x plus 3y is equals to 9 from the point 11, negative 2. What is the distance between the point of intersection of these two lines and this point here? So, Lana, what is the point of intersection of these two equations? These two lines that we were solving, learner, it's like this. Maybe I can write it this way for us to understand. Let this be 5x plus y is equals to 19. And this other line here is negative x plus 3y is equals to 9. These are the equations that we have just solved simultaneously. After solving the two simultaneously, learner, we are getting the point of intersection. The y that we got and the x, look at this. This x and y that you got, learner, they refer to the point of intersection. And therefore, our point of intersection here is 3, 4. I hope it is clear. So from there, learner, it's like you're given another point here, 11, negative 2. So you are being asked, what is this distance? I'm doing this for the sake of understanding. What is this distance, learner, between the point of intersection and this other point here? How do you get this? Maybe I can rewrite it here. You have a point 3, 4, and you have another point 11, negative 2. So how do you find the distance? Distance, learner, or the length between the two, is normally given by what? Square root of, you take x1 minus x2, multiplied square root, plus y1 minus y2, you get the square root, the square. So we come to our points. Let's say this is x1 and x2. So 3 minus 11. 3 minus 11 squared plus, we go to our y's, 4 minus negative 2. 4 minus negative 2. Then you square. Here we are. So this is equals to what, learner? 3 minus 11 is negative 8. So negative 8 squared plus 4 minus minus 2, this becomes plus, so 6 squared. There we are. From there, learner, we are talking of negative 8 squared is 64, plus 6 squared is 36. So you end up with the square root of 100, and therefore square root of 100 is 10. So the distance between our point of intersection, learner, 3, 4, and another point 11, negative 2 is 10 units. So learner, go through that problem slowly, internalizing all the concepts, and therefore I wish you all the best. God bless you.